Well, I'll kind of start off by saying that the power business is a little bit out of my realm anyway. I spent most of my career in aerospace electronics, dealing with picoamps and meg ohms. And when I got over here to the farm and retired, one of the tasks I undertook was to contract for an irrigation well. And so I wound up doing the electrical design on the submersible pump, 60 horsepower, 480 volt, three phase. So I kind of had to switch hats and dig out some old textbooks on power engineering. Anyway, what I'm going to talk about a little bit is what we call neutral to earth voltage, although most people know it about as tingle voltage or stray voltage. And so I thought I'd kind of put together a few slides on that. I hope that, if you have some comments about that, you raise your hand or throw it in, because I may have some things that I haven't thought about here, but I threw these together in response to, I guess, some interest in the subject. So go ahead there, Dave. So the question is, what is it? So it's a term used to describe what we call neutral to earth voltage. That's what the power company wants to call it. NEV is measurable voltage between some metal object and earth. And it's commonly encountered in dairy and livestock operations, but present everywhere, including amateur radio stations. I guess Greg wanted to, I forget, what did you want to call this, the title of this thing, Greg?
Oh, something about bovines.
Oh, yeah.
Stacking bovine stories or whatever.
Yeah, well, I think the next slide may talk about that. Go ahead, Dave. So farmers discovered NEV, when they started using milking machines, and it was expanding farm electrification. And what happened there was the cows are standing on concrete floors, wet floors. And when the farmer went to connect the milking machine, the four hanger downers there got a mild shock. And so that, as well as the watering cups, this is old style farming. This is stuff that happened in the 30s and 40s when they first started discovering this. And Michigan State was, of course, right on top of this, and they identified some of this stray voltage business. I have a 1980 paper written for the American Society of Agricultural Engineers, is what ASAE is about. And they spent quite a bit of time investigating it back even in 1980. Well, what about me? I experienced NEV while working on my vertical antenna, and I'll talk about that a little bit more. I got a few graphics instead of just some wordy stuff here a little bit later. I also had an experience down in South Lyon when the city water department installed plastic water meters. Before that, we just paid a flat rate, but I'm from way back as far as the city finally got around to installing meters, and they were plastic. Well, when they did that, I noticed that this little tingle voltage was present on the outside hose bibs when I was just standing on the ground. I grab a hold of the hose bib to turn it on, I could get a little shock. So, that was another experience that I have. Maybe some of you have experienced this same sort of thing. Well, go ahead, Dave. I had another experience when here in the farm, I had a new HVAC, new furnace and air conditioner put in. And while the installer was working on it, he discovered that there was several volts between the furnace structure and this black pipe that brought the propane service into the house. And he was rather reluctant to connect things up until I explained to him what this was. Apparently they'd never experienced this phenomenon. And then I had another experience here on the old farmhouse. This place was built in 1910, so you can imagine that the plumbing has went through several iterations of rework. But anyway, I discovered that I had some NEV on the plumbing fixtures after they installed a new submersible pump out here for me. And of course, they used a plastic interface between the house copper plumbing and what used to be, just a shallow well pump that was all plumbed in with galvanized pipe. So those are some of the encounters that I had of NEV. I don't know, maybe some of you folks have had the same experience with some other stuff. So go ahead to the next slide there, Dave. And so where does this stuff come from? Well, electric utilities don't make a distinction between neutral grounded power conductors and earth ground, believe it or not. And the normal practice by the utilities is to connect neutral power conductors to earth ground stakes at many, many places. And amateur radio operators are well aware that earth ground is not an equipotential surface because of its poor and variable conductivity. I think we all know about that, or most of us do anyway. So shoot the next slide there, Dave. So what about ground conductivity? Well, I don't know, maybe some of you've got this map in your file someplace, but it illustrates what the ground conductivity looks like in Michigan and a couple of the surrounding states. The numbers on the map are ground conductivity in millisiemens per meter. Over here on the sand pile on the western side of the state, we have about 2. And the rest of the state is about 8. And then if you're lucky, like NA8V over there on the east side in the thumb, he's got 15 millisiemens per meter. My goodness, no wonder he beats us. At least on his vertical antennas for sure. He's got a real gold mine over there. So give me the next slide there, Dave. I'll speak a little bit about some of the units. Soil conductivity is actually a measurement of the salinity of the soils. It has to do, I guess, I'm not the chemist, but it has to do with the ions of sodium, I guess, that does the conductivity stuff. And if you know a little bit about the history, this used to be an undersea area here in Michigan. So I suppose there's some salinity left. It's affected by drainage and vegetation, irrigation, fertilizer, temperature, and so forth. And I thought I ought to talk a little bit about the units. We used to call them micromoles per centimeter for conductivity, but then when they went to the universal naming of it, I guess it went to microsiemens per centimeter, named after, I guess, a German fellow that was interested in telegraphy, as a matter of fact. I think that's where he got his start anyway. You can look up the history on Mr. Siemens, or von Siemens was his name. Distilled water has an electrical conductivity about 0.5 to 3 microsiemens per centimeter, which translates to 0.05 to 0.3 millisiemens per meter, which is the number we use for ground conductivity with the units. I think I did the math on that right in order to convert from microsiemens per centimeter to millisiemens per meter. So anyway, Michigan soil conductivity is on the order of 2 to 15 millisiemens per meter. So that kind of summarizes the conductivity that we're up against. So let's get back to talking about this tingle voltage. So get the next slide there, Dave. So here's a little bit about the power system design. The National Electric Code requires a utility to connect the primary neutral to the secondary neutral on each pole transformer. So that's the first thing you want to keep in mind, is the secondary, in other words, your house supply, is actually the neutral on that's actually connected to the primary neutral. And it also requires that the secondary neutral be hardwired to the building metal system, namely the water usually in most households. And also it requires 2 8-foot ground earth rods at the service entrance. And I think there's some rule about how far the ground rods have to be spaced. And of course, in commercial stuff, other metallic surfaces like the I-beams and rebar and everything else are supposed to be connected to this neutral on the power service. Okay, go to the next slide there, Dave. So effectively, this safety code has required our domestic water system to be hardwired to the neutral of the utility's primary distribution, the primary side. And it also requires that the utility earth ground the primary neutral at least 4 times a mile across the countryside. So out here in the country, almost every utility pole has got a wire going from the primary neutral to a ground stake. And so these requirements are the primary cause for this neutral to earth voltage that everybody experiences. Next slide there, Dave. Now hopefully I won't have so many words now, a couple of pictures to kind of illustrate some of this. Here's a little picture that has a single phase high voltage coming in on the primary and a power line neutral, and it kind of gives you an idea that that ground stake that's down there, we all know that the returning current going back to the substation is going to divide now between the earth ground and the power line neutral. Well, the neutral is quite a bit lower resistance than the ground owing to the conductivity. So there is a potential difference then between earth and power neutral. The next slide, Dave. So this is more like what it looks like when it comes into your house or into a farm or something. Is you have this primary system out there with the pole transformer coming into your house. And the illustration there are the heavy lines are the primary and secondary currents. And then of course there's the earth current flowing from your distribution box in your house, as well as all the other umpteen ground stakes that are present in the transmission of power from the power substation to your house. So that's kind of gives you an idea of all the different ways that the current can sneak around, if you will. Next slide, Dave. And just as an aside, here's a little picture that depicts the fact that this neutral to earth voltage actually creates a common mode situation for such things as your cable that comes into your house or the telephone twisted pair that's supplied off from another supply someplace very remote. And so this voltage difference or this NEV that exists is actually a common mode voltage that exists on the cables coming into your house. So the little modem that you have, it better have pretty good common mode rejection, because there's going to be several volts of this common mode that's on there fighting for attention. So I don't know, I guess that's probably good enough discussion on that one. We can continue on if you want to. Go ahead, Dave. So how about in the radio station? Well, when I opened the coax on my vertical, I measured about 3 to 5 volts between my radial system and the coax shield going back to the station. And you might ask, well, what happens to the NEV when I reconnect the coax to my radial system? Well, it's still there, folks. It's just that my radial system now is connected to the power company's primary neutral. And so it's carrying some of the power system's primary return current. And you might kind of question whether that causes a problem in your station or not. I think Greg kind of hinted about this, and it very well may do. So, of course, this is at 60 cycles and not at 14 megahertz, but be aware that the power currents are not all 60 cycles. There's really an awful lot of trash on the power system currents that are coming into your house. So with the radials reconnected, this tingle voltage is still present, although it might have changed in value. And the station ground being connected to the primary neutral is still separated from an independent earth ground by this NEV. So if you drive an independent ground stake, you'll see the difference still there. It's it hasn't went away. And it just goes to support the idea that earth ground is not this equal potential service, and it's not the same potential as the utility neutral. So good luck with all of that. So anyway, what can be done about this NEV? Well, you can start by inspecting your utility service and power panels. And the objective, of course, is to see if we can improve the conductivity between earth ground and the utility secondary. So is everything tight in your box? And I'm going to talk about that in a little bit because I had an experience with things coming loose. And so I'll have a couple of words to say about that in a minute. And the other question that you need to bring up is, are there any recently installed plastic items that insulate your plumbing from reaching earth ground? That was the big thing that happened here at the farm, is when they put the, the electrical service was connected to the plumbing. The return was the neutral. And of course, when they put the plastic in there, now my plumbing is elevated up by whatever the neutral is on the primary. And something else I guess you can do is you can add additional service panel neutral ground stakes and retighten clamps. So this is all stuff that you can do to try to find out, is the metal very well grounded, at least as best it can be, and to try to reduce the, or try to improve the conductivity. Can NEV be eliminated? Well, nope, you can't eliminate it, but maybe you can move it. And one way that you can do that is you can separate the primary and secondary neutral at the pole transformer. And this NEV now appears between two ground stakes at the pole. And you will have much less NEV on your metal devices in your house after that's done. The utilities will perform this task, especially for customers that have a dedicated pole. And some of the research I did found out that consumers has separated the neutrals on 12,000 farms throughout the state of Michigan. And you can request an NEV inspection. That's the consumer's number. I assume that Cherryland and Detroit Edison will do the same sort of thing, but I don't happen to know what their numbers are, but you can try to, if you're in a mood to try to alleviate the problem, you can do that. So here's a little picture of the pole transformers. And this one on the right shows 7,200 volts for the primaries. Ours out here is 4,800. And of course, there's a little disconnect switch up there with a fuse on the primary side. And you'll notice that the neutral is connected to a neutral wire down there below, and also a ground wire that goes down to the base of the pole. And the other picture on the left shows that there's this the three things coming out of there, the secondaries, of course, and the center tap on the secondary. It's got that strap that they can disconnect that and run a separate ground wire from that center tap to another wire and ground stake on the pole.
Within a few feet of each other, obviously.
What's that?
The second ground post would be a few feet from the other ground post.
Yeah, in my case, they're separated by, I don't know, about a foot.
Oh, okay.
But if you put your voltmeter between the two you'll measure. In my case, it varies. Some days it's 8 volts, some days it's 3 volts, other days it's much lower. Depends on what the current is in the neutral, which depends on how poorly they've got the three-phase balance. The three-phase load, the imbalance on the three-phase load current is handled by the neutral wire. And they try to keep the loads balanced, but it's nearly impossible.
I'm sure.
So here's my distribution, my picture. The one on the right shows the three-phase 4,800 volts up there, and the one transformer that I have with the one phase is connected to the primary. You can see a little clip up there on one of the 3 wires. The very bottom wire is Mr. AT&T there with the twisted pair that gives me my DSL with limited bandwidth. And the wire above that is the neutral. And if you look carefully on the left-hand picture, you see a little sign that the consumers have put up there that says it's got a split neutral.
Oh, yeah.
That's to notify the service people that the neutral has been split on my service. And over here on the left is my service entrance, which was recently redone about, I don't know, 4 or 5 years ago. I really fixed up the old farmhouse. And so the meter box is fed with an overhead wire going out to the pole that I showed you a minute before. And the big box down below is an addition that's now required on all new installations. And that's a disconnect for the main power going into the house. And also, by the way, to my garage, there's an underground cable going out to the garage. And then there's one also that feeds the air conditioner. And the reason for that is that the fire people want to be able to, if you have a fire in your house, they want to be able to shut off the power. And they used to reach out and cut the cables that come into the house.
Oh.
Well, now they have a way that they can disconnect it outside the house without having to go into the house. And it's mandatory now. I guess you have these disconnect boxes on the outside on new installations. I wanted to talk about the 3 wires that come into the meter. This little graphic on the on how that works. The neutral wire comes in. There's to the center, and that's grounded to that box. And then there's a ground stake that comes off from that usually, although I have another picture that shows you a more updated picture on that. But suffice it to say that there's the power wires come in, and there's these clamp plates with a screw on there. Well, I had a situation in my house where after a few years of operation, I lost one side of the 220 coming in. I had 110 on one or 115 on one side, but nothing on the other side. Well, after I got my voltmeter, I figured the problem was in the meter box. So boy, consumers came out in a hurry when I called them about that. And they pulled the meter, and sure enough, the one wire coming from the service was slightly loose. He put his wrench on there and tightened it up, and everything is just great. Well, that prompted Mr. Engineer to look into these service boxes, and there's a torque requirement on those clamp plates. But when's the last time you ever saw an electrician with a torque wrench in his toolbox?
Yeah.
Never. So anyway, that's and then now the other thing I'm going to point out here shortly is this business about the neutral. The neutral has a big lug on there too, where the 2 wires are connected together. So a lot of this stuff is safety oriented here, not much ham radio. This is more a picture of what a modern installation is required to be. The thing on the left is the big box that's got the main disconnect. And the smaller box is the meter box over there. And the real ground is in this one strip that's in the panel that's on the outside of the house there, in which both the neutral and the green wire are connected together along with the ground stake. And so then it goes through this feed through, and you'll notice that they're non-metallic feed throughs that go through there, so that the box inside the house now is connected. This is where the neutral and the metallic ground are separated in the house. And all your 3-wire services for 115 volt stuff, the green wire goes to this little guy on the bottom there, which goes to the ground stake, and the white wire, of course, goes to the neutral. So right there is where the separation is, and it's against the rules to ever connect the green wire and the white wire. So sometimes you have to watch, if you're in an old house like this one, the do-it-yourselfers sometimes violated that rule. So I've completely rewired this old farmhouse, and it's all to code now anyway. So there's a little picture about what the service connections ought to look like. Go ahead, Dave. I'm almost to the end here, I think. Here's an illustration of what happens if that neutral wire ever comes loose between your pole and any part of your service. It's a big problem, because if you notice what those numbers are, since the ground has such poor conductivity, every piece of metal that's connected to your service now is going to be at some crazy voltage above ground. And of course, anything that's connected to line number 2 there is going to get blown out. So this is the big problem that you have to be really aware of, is if that neutral wire going all the way out to the pole ever gets separated, you've got a big safety issue. So they do have new devices now that protect against that, and I'm not sure what the latest is on that, but I think they've got some mains protection devices now that'll protect against that, to shut stuff off.
Whoa.
So this is next to the last slide. I'm almost done. So while I researched this for stuff for the presentation here, I discovered that in very remote areas like Alaska and Australia, primary power distribution over real long distances is made using only one primary wire. That just astounded me. Earth ground is used solely for the primary return current. There's no return wire. They're saving money on copper. Or I guess aluminum now is what they use, of course. So it's called single wire earth return. So I got a little graphic on the next page that shows that, and then I'm done. So here's a typical connection out in the hinterlands in VK6 land maybe, or whatever, in which the substation now puts a 20,000 volt, much higher voltage than we use for secondary for primary distribution. And then it totally relies on the earth return. So you can imagine that their regulation is not too great out there in the in parts of Alaska that are separated by many miles with this, what they call single wire earth return. Glad you don't live out there, folks.